Good morning students, I am Vetri Chervi from Vetri and Vetri Neet Chemistry. Today's video topic is General Organic Chemistry. Important topic is Isomerism. Now let us see the question. Number of isomers of C5H6 Ames question. Here options are 2, 3, 4, 5. So like question is like that mean first you have to find out the degree of, let us see the formula is to find out number of the double bond, or we can call it as a degree of your, that is call it as a double bond. Yes, if formula is equal to, now here degree of unsaturation we can call it, or degree of double bond equal. This is called double bond equivalence or degree of unsaturation. Formula is number of carbon atom plus 1 minus of number of hydrogen plus number of halogen minus number of nitrogen divided by 2. This is in the bracket. So this is to find out the degree of unsaturation. Now regarding this formula, carbon is 5 number. So 5 plus 1 minus of this is, and number of hydrogen is 6 divided by 2. So what is you are getting is 6 minus 3. So 6 minus 3, how much you are having is 3. So now what is it? You have to get the degree of unsaturation should be 3. The meaning is whatever structure possible, there should be either the unsaturation should be in the number of double bond, or it should be in the number of your ring structure. Now let us write this formula. C5H6 possible structure, very important, possible structure with 2 number. This is 3 number of unsaturation. This with that care I am putting now. First I am starting with them one structure with the carbon number 5. This is pentagonal. Carbon 5 and hydrogen 6 is matching, of course. 5 carbon and each is having hydrogen. Okay, now this is with this is with this. Here the important point is each double bond is 1 unsaturation. Now 1, 2 and the ring is 1 more saturation. So now 2 double bond plus 1 ring, totally 3 unsaturation, and the carbon is 5, hydrogen you can find out. Here it is 1 hydrogen, hydrogen, hydrogen and hydrogen, and here it is H2. 2, 3, 4, 5, 6. So the structure is ready. Like that I am going to the next structure. Here 5 carbon. Now I am putting the ring with the 4 carbon, and then this is the 2 double bond. Here 5 carbon, 1 carbon I have to put it. Now this is, here you can call it as a methyl group. Now find out the unsaturation. 2 double bond with the ring, 3 unsaturation is over, carbon 5 is over, hydrogen 6 we have to verify. So here hydrogen each corner, here it is 1 hydrogen, 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 3 plus 3 6. Okay, here there is no hydrogen at all. So this is also correct structure. Again go to the 5, 4. I am putting the ring with the 3 numbers. Here it is carbon totally 5. So 3 plus 1, 4, again the 5. Here next one is we need the double bond. Unsaturation should be 3 numbers. So here 1 double bond I am putting 1, 2 and the ring is 3. So 3 unsaturation is ready. Complete the valency 2 numbers. So here it is. Okay. Now find out the hydrogen. Here hydrogen is 1 and here 1. Here it is 1. So 2, 3, 4, 5, 6. So these are the possible structures for this formula. So my option is B. So the question is very standard question. You see it is the question of Ames 2012. So this type of question we can expect for this year. So what is simple question? Number of isomers possible. That's all it is given. You find out the what is it called double bond equivalent with this formula, and the equivalence is 3 number. So you design the structure by keeping the degree of unsaturation 3 number. That is enough. Now let us go to the next question. Organic compound with the molecular formula C4H8O2 cannot have the functional group. Same pattern is here. What are the functional groups are there? acid, ester, dialdehyde and cyclic diol, which functional group cannot. So now let us go with the number of oxygen atoms. All are having the 2. We cannot eliminate. Now I am going to do the other methodology like what we did it here. Same double bond equivalence let us calculate here. What is it? Carbon plus 1 and the formula is minus number of hydrogen. Next one, this is divided by 2. Yes, number of carbon is, what is your carbon is here 4 plus 1 and here hydrogen is 8 by 2. What you are getting is 5 minus 4. So what is your double bond unsaturation is only 1. Okay, now let us, this is in this formula, there is no oxygen at all, eliminate. Now let us go to your acid. Let me write the acid. You are having the double bond with the functional group of acid. Your double bond character, it is 1 pi bond. So this is possible. Now let us see the ester mean again the same functional group only for your ester. So there is only one double bond. So ester also can possible with the functional isomer. Now let us go to the dialdehyde. What is the aldehyde functional group is? This is your one aldehyde group. Another aldehyde group is this is. What is understood? One molecule should have 2 pi bond, that is called degree of unsaturation should be 2 mean it is not possible dialdehyde. So this cannot be written. Let us see a cyclic diol. What is the formula for cyclic diol is? This is carbon number 4 and here one OH and here one OH. Verify the formula. Carbon 4, hydrogen 8. How we are getting hydrogen 8 is here 1, 2, 3. Here one hydrogen, one hydrogen. You add the hydrogen. 2, 4, 5, 6, 7, 8. Oxygen 2. This is a cyclic diol which is having only one unsaturation, that is only the ring. So unsaturation means either the double bond, that is pi bond, or the your cycle. So based on this one, today I am giving, this is the previous year question. This is the, we can expect this type of question for this year. Okay, again repeating, find out the number of equivalent or number of unsaturation, apply in the functional group and eliminate, and your answer is cannot have functional group is your C is the answer. Okay, let us go to the next question. Here questions are very simple, children. Which of the following compounds of chain isomers of C5H10O? Now let us see what is the meaning of chain isomer mean. There should be different in PC or the side chain. This is the knowledge. What is the knowledge is the different in the parent chain or the side chain. This is point number 1. Number 2, very important, they should have the same functional group. Now let us see, for each one put the diagram. 2-methyl butanol. Butanol means 4 carbon. 1, 2, 3, 4 with aldehyde. This is I am putting the aldehyde. 1, 2, 3, 4 and 2-methyl. So this is the Roman number 1. Number 2 is 2-pentanol. 1, 2, 3, 4, 5. 5, now put it 1, 2, 3, 4, 5 on second carbon atom double bond O. And this is Roman number 2. Number 3 is pentanol. 1, 2, 3, 4, 5. CHO, that is your aldehyde. 1, 2, 3, 4, 5. Now what is the tips for chain isomer? Different in the parent chain. Let us see how many carbon chain is here in the parent chain. Already written. It is having 4 carbon. It is having 5 carbon. It is having 5 carbon. So now I am going to the option 1 and 2. You compare 1 and 2. Both are different in carbon chain, but the functional groups are not same. One is aldehyde, one is ketone. So it is not correct. Now I am going to the option B. 1 and 3. 1 and 3. Both are having the carbon chain is different. Different in the parent chain is correct. Same functional group. So your option 1 and 3 are the chain isomers. So this is the answer. Let us go and eliminate the remaining 2 also. 2 and 3. What happened to the 2 and 3? Both are having 5 carbon. Same parent chain. So it is not correct answer. D is 1, 2, 3. It is not correct. So like that we have to approach. Okay, before going to that, each one you put the diagram, or you can do it as a shortcut manner, different in parent chain. Now I am doing, this is butanol 4 carbon, pentanone 5 carbon. So any two, this and this, only different only can be the isomer. Next point is that should be having same functional group. Aldehyde is there, aldehyde is there. So what is it? 1 and 3 are the isomers. Now you can see like that also you can approach the answer. Okay, instead of putting the diagram, you can go with the number of carbon. Butanol 4 carbon, pentanone 5. So carbon is identified. Then these are the different carbon, but the different carbon is okay for chain isomer, but functional groups are different. So it is not correct. So now this is correct. Both your functional group also the same. So your option is 1 and 3. So either this way or this way you can do, which is your convenient. Okay, next we are going to the select the pair of chain isomers from the following. Let us apply the same trick. What is it? The first one, I am writing first one. Number of carbon, it is 5. Number 2, what is the carbon is 1, 2, 3, 4, 5. Carbon, okay. Number 3, 1, 2, 3, 4 only. Chain is having 4. And then fourth one, how many carbon? 1, 2, 3, 4, 5. This is called fifth carbon. Okay. Now the pair of chain isomer. So what is the thing is, pair of chain isomer is, what is the knowledge is? Different in parent chain. That is important. Now the first, now I am going to see the option. 1 and 2 is both are 5C. So it is not correct answer. Next 2 and 4. Now take it 2 and 4. Both are same carbon number. So it is not correct answer. C 1 and 4. 1 and 4. That is a carbon answer same. So it is not correct. So D 2 and 3. 2 and 3. Both are different in carbon. That is different in PC. So it is the chain isomer. Like that you can approach the some children. Okay, one more verification. 2 and 4. You see here. Both are having the formula. Now I am going to write the formula for 2 and 3. Carbon, one you can find 1, 2, 3, 4, 5. Carbon is 5. Hydrogen is, it should be the 10 because it is the CnH2n because it is the alkene. Let us verify. Hydrogen 3, 4, 5, 6, 7, 3, yes 10. So both are having the same formula, same functional group, but different in the carbon chain. So it is match for the definition for chain isomer. So prepare well children. Next video I will put it. Thank you children.